Hello everyone, welcome to the session on energy engineering. I am Satish H, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So this session we are going to start with begin with a new module, that is solar energy. So this is module number 3. So that is discusses about solar energy. Okay. So in this module you are going to study about what do you mean by the solar energy. So brief introduction about that, and then you are going to study about various measuring instruments of solar radiation or radiation data, and also you are going to study about how do you harness or convert this solar energy. Okay, so there are basically two systems, that is thermal systems, and one more is photovoltaic systems. Okay, so we are going to study about those things. So basically the solar energy, okay, energy is nothing but it is a capacity to do work. Solar energy means energy which is coming from the sun, so that is known as the solar energy. So this solar energy reaches the Earth's atmosphere, okay, so at the surface of the Earth, okay, in the form of a waves, that is called as electromagnetic waves. So we can utilize that energy which is contained in these electromagnetic waves or the radiations for the various purposes. For example, you might have seen like in everybody's home, one of the like utilization or the application where this solar energy can be utilized is solar water heaters. So what we do is we install this solar heaters on the top of the house. So and then those water heaters, they will absorb the heat energy that is stored in these electromagnetic waves, and then that energy can be converted, okay, into the in order to heat up the water, okay, that is used for various applications. Similarly, you might have seen this photovoltaic cells. So in this photovoltaic cells converts the solar energy directly into the electrical energy. So for example, some of the street lights are solar powered, where we have a solar panels inside which we have these photovoltaic cells. Those photovoltaic cells helps to convert this electromagnetic energy, that is the solar energy, into the light energy or the electrical energy. Similarly, there are various applications, and then it has a huge potential where we can harness the freely available energy in the nature, that is the solar energy. Okay, so nowadays we are speaking about the pollution. Okay, so in order to reduce the pollution, we need to like a technology is looking for the solar powered cars. Okay, so the cars which are powered by the solar energy. Okay, likewise there are huge potential in this area, so where we can harness this for like energy which is contained in the sun. Okay, so in order to do the various like a useful energy, various works. Okay, so coming to the introduction of this. Okay, in this session I am going to discuss about firstly about the introduction. So what do you mean by the solar energy, and then what are some of the advantages and disadvantages of this solar energy? What are the alternative sources of energy that we have that is derived from the solar energy? And later on like a thermal, what are the solar energy conversion systems? So these conversion systems we will going to study in detail. I am going to introduce them briefly in this introduction class about the solar energy. So coming back to this one, so we have a sun and then the earth. Okay, so sun, the energy from the sun, okay, can be have this spectrum of rays. Okay, so it's starting from shorter wavelengths. Okay, so that is gamma rays and X-rays are these shorter wavelengths, and then longer wavelengths are radio waves. Okay, in between them we have ultraviolet rays, okay, as well as visible and then infrared rays. Okay, so the spectrum which is reaching the earth, okay, that falls in this one, that is in between, that is ultraviolet, visible and infrared. Okay, these rays, okay, are the spectrum of rays that is reaching the surface of the earth, okay. So this is about like how, like what is the different waves, okay, that is coming from the sun, and then what is the rays which are reaching the surface of the earth, okay. As I said before, these are electromagnetic waves, okay. So those the energy which is coming from the sun is electromagnetic waves, okay, are the electromagnetic radiations. So we have sustain life and then affects climate change, okay. So we call the sun as a primary source of energy. You take whatever the sources of energy on the face of the earth, so that is are the indirect sources of solar energy, okay. So for the energy or the life to sustain on the face of the earth, okay, so we need like a solar energy, okay. So the plants, they produce the food with the help of the energy from the sun, okay. So through the photosynthesis process, okay. So like this, the energy that is coming from the sun is essential, okay. So in order to sustain life on the face of the earth, okay. And then it affects the climatic changes, okay. So what we have, the seasons, different seasons, summer, winter, and then rainy seasons, those are cycles are affected by this the sun, okay. So and then we have like how does the energy, that is enormous amount of energy that is produced in the sun, we know that there are two types of reactions. One is fusion reaction and fission reaction. These are the nuclear reaction. In the case of fission reaction, we divide the nuclei, and then while dividing it, like kind of energy is produced, okay. That energy can be used to do the useful work, okay. In the case of the fusion means combining, okay, or uniting. So we kind of take this like hydrogen atoms, okay. So in the sun, the 4 hydrogen nuclei combine together in order to form this helium, okay. So and then energy, okay, is released. This is represented with the equation here, okay. So that is 4,1H1, okay, that is equal to 2 times of helium to the power of 4 plus 26.7 mega electrovolts, okay. This is the amount of energy that is released, okay. So by combining because of this fusion process. And then we have a surface temperature, okay. We know that the sun has like an enormous amount of energy is released, okay. So the surface temperature is in the order of 5,800 degree Kelvin, okay. So much, okay, that is very high temperatures, okay, on the surface of the sun can be encountered, okay. So this is about a brief introduction, okay. So what do you mean by, like, how does the sun energy is reaching the earth, and then what do you mean by electromagnetic waves, and what are the functions, okay. What is reaction? Basically fusion reaction that is used to like a chemical reaction that is used to liberate enormous amount of energy on the earth, from the sun, that will reach eventually to the earth. So coming to this indirect form of energies, okay, as I said before, sun is the primary source of energy. You can take any form of energy on the surface of the earth, okay. So that is coming from the sun, okay. So biomass energy, okay. So how it is related is, okay, the biomass, the plants prepare their food, okay, with the help of a photosynthesis process by absorbing the energy from the sun, okay. So that biomass energy, okay, so when these plants grow and then like they decay, okay, that is like accumulated in the sediments, okay, beneath the surface of the earth, okay. So that will give you the biomass energy that we are utilizing to do the various works. And then tidal energy, that is energy which is stored in the like a waves. So that is rising and falling of the waves, okay. That phenomenon can be used to harness this energy which is in the waves, that is called as a tidal energy, okay. So that is also because of the tides are generated, okay, because of the gravitational pull, okay, of the sun and then the moon and then the earth, okay. So that is, we can call it as indirectly, okay, from the sun only we are getting this tidal energy. We know that this is the fossil fuels, as I was explaining, the plants which extract the energy from the sun, and then the fossil fuels over the millions of years, the sediments of form. So that will result in fossil fuels like petroleum, okay, diesel, okay, and then crude oil, etc. So and then we come back, coming to the what are the advantages of the solar energy, okay. It is a clean energy. That is the first advantage of the solar energy. What do you mean by the clean energy? If you take this other sources of energy, for example, coal, okay, or the petrol or diesels, for example, these are the fossil fuels, okay. When you burn these type of fuels, okay, like a wood, okay, coal or charcoal or a petrol or diesels, they will liberate some of the harmful gases. The harmful gases might be like a carbon monoxide, and then greenhouse gases like carbon dioxide, etc. Okay, so this like liberated pollutants, okay, when they like come into the atmosphere, okay, so they will result in various other complications, okay, like increased amount of carbon dioxide in the atmosphere might result in the global warming, okay. The carbon monoxide, which is harmful for the like living beings on the face of the earth, okay, whereas this solar energy is the clean energy, okay. There is no harmful gases or the pollutants produced because of the conversion of energy, okay, from the like a solar energy to the other forms of energy. And then it is inexhaustible, okay, so it is nothing but renewable sources of energy. So we have non-renewable sources of energy like fossil fuels, okay, so coal, petroleum, diesel oil, kerosene, okay, all these like forms of fuels are going to exhaust over the period of time, okay. If you keep on utilizing them, they are going to exhaust over the period of time, whereas solar energy is available, okay, it is renewable sources of energy, it is inexhaustible, okay, it is continuously it is produced, okay. So that is one of the very, very important form of energy, okay. So and then abundantly and universally available, okay. So if you take on the face of the earth, okay, so it is available in a very large quantities, that is it is available abundantly, and then it is universally available everywhere on the earth, okay, it is available, okay. So those are some of the advantages of the solar energy, okay. Coming to what are the disadvantages of like a solar energy. One is dilute form of energy, okay, it is not concentrated, okay, it is a dilute form of energy. That is one of the disadvantage of solar energy. And then available intermittently and uncertainly, okay. So for example, intermittently means, okay, if you take the day, okay, so during the night times you don't have this like a sun, okay, that is you don't get the energy from the sun. So that means during the daytime only you have to the availability of this like energy from the sun is available. That means it is intermittently available, it is not continuously available. For example, if you take a fossil fuels or the like a hydroelectric power plants, okay, there you can produce throughout the day 24 hours, okay, the energy is continuously produced, whereas in the case of a solar, so like it depends upon, okay, day and night, okay, during the night time no solar energy is available, as well as if the weather is cloudy, and then that is also affects the energy availability on the surface of the earth, okay. So that is one of the disadvantages, available intermittently and uncertainly. So one more is not steadily and continuously, it is not available continuously, okay, that is nothing but it is available intermittently only, okay. So there is a gap between like availability of the solar energy, okay. So these are some of the advantages and disadvantages of the solar energy, okay. So there is a huge potential, as I told before, in order to like utilize this energy, okay, enormous amount of energy abundantly available, and it is available universally. So it is also having an advantage of it is a clean source of energy, okay. So that makes it, okay, so like in order to utilize this solar energy more and more. So there are some systems like solar energy utilization techniques, okay. So how do you convert this energy which is available from the sun, okay, so into other forms of energy, okay. It is a conversion of energies, okay, from the one form of energy to the other form of energy. Here the input energy is solar energy to the other forms of energy. First one is we have a thermal systems, and then second one is a solar photovoltaic, okay. What do you mean by the thermal systems, okay? So let us see some example. They are used in like a domestic and industrial needs, and solar water heater, and drying and process industries. Okay, so in this case, the energy which is coming from the sun is converted into the heat energy or the thermal energy. Okay, so for the one of the example is solar water heater. Okay, what we do is we install this water heaters, okay, the panel on the top of the house or on the terrace, so where the energy from the sun incident upon this like a solar water heater, okay, where there are tube arrangement, and then that energy from the sun is absorbed through these tubes. Okay, the like fluid is flowing, so normally the water, okay, that water absorbs the energy from the sun, and then that cold water is heated up to the hot water. Okay, so what we are basically doing is we are converting the energy which is coming from the sun into the thermal energy or the heat energy. Okay, so as I said, so these are some of the examples, okay, where we can use this thermal systems. Okay, one is domestic and industrial needs, and then solar water heaters and drying and process industries. So similarly, we have one more type of like a solar energy utilization techniques. Okay, so how do you utilize this energy? Okay, which technique you use? Okay, so the second technique that we are using to utilize this solar energy is solar photovoltaic. Okay, so here solar energy is directly converted into the electrical energy. Okay, so in order to convert this solar energy directly into the electrical energy, so what we need is we need a device. That device is called as a solar photovoltaic cell or solar cell, we call. Okay, in short, it is called as a solar cell or solar photovoltaic cell. Okay, so that is a device that we are using. Okay, so and then what are the uses of this solar photovoltaic cell or solar cell is, okay, so they are used in space satellites. Okay, so you know that the space satellites, when they reach the outer space, okay, so they need energy, so they have kind of these solar panels, okay, that containing the solar photovoltaic cells. Okay, so when they open up, these photovoltaic cells absorb the energy, okay, which is there in the space that is coming from the sun, and then that energy which is absorbed is converted into the electrical energy. That electrical energy is used to move the satellite, okay, around the planets. So and also we have radio communication. Okay, so in that case also the energy from the sun is directly converted into the electrical energy that we will use for the radio communications. And then marine warning lights. Okay, so next one is when you have this marine, okay, so ocean, some of the alarms are the warning lights, okay, that can also use this one. Okay, so some of the examples that you might have seen is, okay, some of the street lights are using some photovoltaic systems. Okay, so like during the daytime they have these panels that will collect or receive the energy from the sun, and then that is stored in battery, the energy from the solar panel, and then that energy which is stored in the battery can be used to light up the lights, okay, during the night time. So that is called as like that is a common example that you are going to see, okay, in your daily lives. Okay, that is using of solar energy in order to light up these street lights. Then what are the advantages and disadvantages of solar photovoltaic cells or the solar photovoltaic technique of utilizing solar energy is it is a direct energy conversion. So there are no intermediate components, there are no moving components. That is one of the major advantage of this one. Okay, it is direct energy conversion from the solar energy to the electrical energy. And then they are quite compatible and then durable. Quite means since there are any moving parts, okay, inside this solar photovoltaic cells, okay, there is not much noise is involved, and then they are compatible. Okay, their size is like a compact in size. Okay, so and then one more thing is they are durable. Okay, they can be used for longer period of time. Okay, so that is the one of the advantage. and then no distribution network is necessary. Okay, so distribution network is also eliminated, okay, if you use this solar photovoltaic cells. And some of the disadvantages are they have low efficiency and then expensive. Okay, so the conversion of the solar energy into the electrical energy, okay, the efficiency is less in the case of like a solar photovoltaic cells, and then they are little bit expensive. Those solar cells are economically costlier. Okay, so those are the some of the disadvantages of these solar photovoltaic systems. Okay, so this is about the introduction. Okay, so what do you mean by the solar energy? That is basically electromagnetic waves that is coming from the sun, and then like all the forms of like a life on the earth, it is because of the solar energy. Okay, so that is, it sustains lives and affects the climatic changes. The fusion reaction is the one which is responsible for the production of the energy, okay, in the sun, that is radiated to the outer space, okay, eventually reaching the face of the earth. So and then we have seen some of the what are the advantages, and then indirect forms or the alternate forms of solar energy. If you take any form of energy on the solar, for example, hydroelectric power plants or wind energy is because of solar energy. Tidal energy, ocean thermal energy is because of the like a solar because of the sun or the solar. And then biomass energy, okay, all are indirect forms of energy. Okay, sun is the primary source of energy for us. And then what are the some of the advantages? Clean energy, and then it is inexhaustible, and then abundantly and universally used. And some of the disadvantages of solar energy we have discussed. And then what are the solar energy conversion techniques? There are thermal systems and then photovoltaic systems. In the thermal systems, the energy from the sun is converted into the thermal energy. In the photovoltaic conversion systems, we convert this solar energy into the directly into the electrical energy. Okay, so in this module you are going to study about what are the different methods or the techniques used for the measure of solar radiation data. That is one part. And then in the other part you are going to study various systems. Okay, as I told you, there are thermal systems and solar photovoltaic systems. Okay, so what do you mean by the like a solar thermal systems, and then what are different types in them? Okay, and then photovoltaic systems also. What do you mean by photovoltaic systems, and what are the different types that are involved? Okay, so these are the things we are going to study under this module. So after a brief introduction to the solar energy, so now let us discuss about the second topic, that is the measurement of solar radiation data. So basically the solar radiation, okay, so which is coming from the sun, can be measured, okay, using different instruments. The instruments are listed out here. The first one is a pyranometer, so which is used to measure, the pyranometer is used to measure global radiation. So on an horizontal surfaces normally, so also it can be used in order to measure the global radiations on the inclined surfaces as well. So this is about the pyranometer. I repeat, the pyranometer is used to measure the global radiation on a horizontal surfaces, or also it can be used to measure the global radiation on the inclined surfaces. And the second instrument, that is the pyrheliometer, that is used to measure the beam radiation. Okay, so beam radiation from the sun, so using a long narrow tube. So the pyrheliometer is used to measure the beam radiation using a long narrow tube. And then the third type of the instrument, which is called as a sunshine recorder. So if you want to measure the amount of sunshine in hours in a day, okay, you can use this instrument which is called as a sunshine recorder. Okay, so basically in order to measure the like a solar radiation data, we make use of three important devices. So are the instruments, they are called as pyranometer, which measures global radiation. The second one is pyrheliometer, which measures the beam radiation, and then the sunshine recorder, which measures in hours how many hours there was a sunshine in a day. Okay, so this is about the three types of instruments. So now let us discuss about the three instruments in detail with the help of the sketch. What is the construction, and then how does they work, and then what they what they are used to measure. The first one is pyranometer. As I said before, it is used to measure the global radiations, okay, on the horizontal surfaces as well as on the inclined surfaces. Okay, coming to the construction, okay, the schematic representation of this pyranometer is as shown in this figure here. So it consists of mainly the parts are the thermopile. Okay, this is a thermopile here. Okay, so which is consist of hot and cold junctions. Okay, so we have a circular, a blackened observer, that is a sensitive element. Okay, this is a circular, a blackened observer here, and then it is this circular blackened observer is protected with the help of this the glass domes. Okay, the glass domes are in the shape of hemispherical shape. Okay, so and then we have this radiation which is coming from the sun. Okay, so how does they function is, it is the difference of temperature between this cold junction and then hot junction is a function of radiation falling on the sensitive surface. I repeat that the difference of temperature between hot and cold junctions is a function of radiation falling on the sensitive surface. Okay, here this radiation which is falling on this sensitive surfaces, after it is passing through this hemispherical glass domes, the difference in temperatures, okay, so between cold and hot junctions will give you this function of radiation falling on the sensitive surfaces here. Okay, so this is about a pyranometer. Okay, so basically using this pyranometer we measure this global radiation, okay, on the horizontal as well as inclined surfaces. It consists of, okay, a blackened observer which is circular in shape, which is called, we have a thermopile which consists of a hot junction which is normally exposed to the sunshine, and then the cold junction which is normally shaded, and then this whole thing, that is this sensitive material, is enclosed within a hemispherical the glass domes. Okay, so when the radiation falls on these glass domes which is absorbed by the sensitive element here, this is a sensitive element, the temperature difference between the hot and cold junctions is the function of, okay, the radiation falling on the like a sensitive surface. That glass domes what we are using, okay, it will protect this sensitive element. These are the glass domes we are using that will protect the sensitive elements from wind and the rain. Okay, it is basically a protection purpose for this instrument. Okay, so this is about the pyranometer. Next we will discuss about the second instrument, that is pyrheliometer. Okay, so as I was explaining before, the pyrheliometer is used to measure the beam radiation. Okay, only single a beam of radiation, okay, from the sun, okay, using a long and narrow tube which is called a collimator tube. Okay, so coming to this construction of this pyrheliometer, okay, so it consists of a collimator, okay, it consists of collimator tube, okay, which is blackened. This portion is called as a long collimator tube, okay, so which is used to, okay, collect this sun ray, okay, single beam of radiation is collected through this a long collimator tube. Okay, so this inside surface of this collimator tube is blackened. Okay, so and then which has a diaphragms, okay, at certain distance inside the at a regular distance, okay, inside this long collimator tube. Okay, and also it consists of a wire wound thermopile. Okay, so here it is wire wound thermopile, so which is inside at the end of this long collimator tube. So this is having a sensitivity of 8 microvolts per watt per meter square. Okay, and then this tube is sealed with the dry air. Okay, this whole of this long collimator tube is sealed with the dry air. That is in order to avoid, okay, absorption of these radiations by the water vapor. Okay, there might be some water vapor present inside this a collimator tube. Okay, in order to avoid the absorption of radiation by the water vapor, we use the dry air, okay, as a sealing material, okay, inside this collimator tube. Okay, so after this we have this tracer. That tracer helps to record this readings continuously, and then we have this pivots, okay, for two-way rotation. Okay, in order to adjust this instruments using these pivots, okay, so for the two-axis rotation, okay, so with the help of this we can adjust the instruments. Okay, so coming to working principle, so through this tube a narrow beam of radiation, okay, enters this tube here. So and then the tube inside this is like a painted, or it is a blackened tube here, and then it is absorbed by this sensing element, that is a wire wound thermocouple. So that will measure this beam radiation. Okay, so that is how the pyrheliometer, okay, so works. Okay, this is about the construction and then the working principle. So basically it consists of it is used to measure the beam radiation. It consists of a tube, a long narrow tube which is called as a collimator tube, and then we have a diaphragms, and inside this tube it is blackened, and then a single ray of beam, okay, or the radiation enters this tube, and then it is absorbed by a thermopile, a wire wound thermopile kept at the bottom of this the long narrow tube. Okay, so and then that thermopile will measure the, okay, beam radiation. So in order to adjust the axis, we have a pivot for two axis rotation, and then also a tracer in order to record the readings continuously. Okay, this is about the second instrument which is used to measure the beam radiation using pyrheliometer. Okay, so next we will discuss about the sunshine recorder. So next we will discuss about the third type of this instrument, which is called as a sunshine recorder. As I was explaining before, sunshine recorders are used to measure the sunshine during the day. Okay, that is measures the sunshine in terms of hours. Okay, how many hours the sunshine was there, okay, in a day. Okay, so that is recorded using this the instrument which is called as a sunshine recorder. So basically it consists of, okay, a glass sphere. This is a spherical lens, or we can call it as a glass sphere. The diameter of that glass sphere is approximately about 10 centimeters. So that glass sphere, okay, is mounted inside this spherical bowl section. We have a kind of a spherical, that we have a glass sphere here. Okay, so this is mounted, okay, on the horizontal platform. Okay, basically the sunshine recorder consists of a spherical lens or glass sphere of about 100 centimeter diameter, and then which is mounted inside this spherical bowl section. So the whole setup is mounted on this horizontal platform here. Okay, so and then as the sun rays are focused, okay, the radiation, okay, which is coming from the sun, or the rays of the sun which is coming from the sun are focused, okay, sharply at the spot. Okay, so we kind of using this spherical lens, we collect this radiation from the sun, or the rays from the sun, and then those are, okay, focused at the spot, okay, onto the card which is held in a groove. Okay, onto the card, a card which is held in a groove, and then card is made up of a special paper. Okay, a card which is held in a groove, it is made up of a special paper, so which has a time scale. Okay, the scale is like a marked on this a special paper or the card. So and then as this sun rays which are absorbed by this spherical lens, and then when those are focused onto this card or the special paper, okay, so it starts to burn. Okay, so because all the sun rays are collected by the lens and then it is focused onto the paper, it starts to burn the paper, okay, along the path. So along the path, it starts to burn the paper. Length of the trace, okay, as the day passes, the sun starts moving, okay. So and then the length of this a path or the burnt path also increases as the sun moves, okay. So that is the measure of the duration, okay. So how much length the special paper or the card is burnt, okay. So using that time scale which is mounted on this paper, that is a measure of how many hours of sunshine was there in a day, okay. So this is how this sunshine recorder works. So basically it is measure the like a number of sunshine hours in a day. It consists of a spherical glass, okay, and then which is mounted on a spherical section or a ball. The whole setup is mounted on horizontal platform here. So when the radiation from the sun which are absorbed by this spherical glass and then focused onto the spot, okay, where this card which is made up of special paper is kept in a groove, and then when this the focused radiation falls on this paper or a special paper, it starts to burn, okay. As the sun moves, okay, so the tracer or the length of this burnt paper increases, okay. So this number of hours in a day, okay, so is the measure of how long is the length of this burnt trace, okay, or the burnt length of the paper, okay. That is measured using the time scale, okay. So that is about the different, okay, three types of instruments that are used to measure the solar radiations data. The first one is the pyranometer, which is used to measure the global radiation, and the pyrheliometer, beam radiation, and then a sunshine recorder, which is used to like measure the sunshine hours in a day, okay. So thank you so much.